How to conduct an agriculture-based experiment. Conducting an agricultural experiment is not just a scientific endeavor. It is a gateway to innovation, sustainability, and improved food security. As the global population continues to rise, the demand for efficient agricultural practices becomes increasingly critical. Whether you are a seasoned agronomist or a novice farmer, understanding how to conduct an agricultural experiment can empower you to make informed decisions that enhance crop yield, soil health, and overall farm productivity. This article will guide you through the essential steps of conducting an agricultural experiment, ensuring that your efforts yield meaningful and actionable results. Defining your research question. The first step in conducting an agricultural experiment is to define a clear and concise research question. This question should address a specific problem or hypothesis within the realm of agriculture. For instance, you might ask, how does varying nitrogen fertilizer application affect corn yield? A well-defined question not only guides your research, but also helps in determining the scope of your experiment. Once you have your research question, it's essential to conduct a literature review. This involves reviewing existing studies related to your topic to understand what has already been discovered and where gaps in knowledge exist. By doing this, you can refine your question further and ensure that your experiment contributes new insights to the field. Additionally, consider the practical implications of your research question. Will it address a pressing issue faced by farmers? Will it lead to more sustainable practices? Keeping these factors in mind will help you stay focused on the ultimate goal of your experiment. Designing the experiment. With a clear research question in hand, the next step is designing your experiment. This involves selecting the appropriate methodology and determining how you will collect data. The design should include control and treatment groups to allow for comparative analysis. For example, if you are testing different fertilizer types, one group should receive no fertilizer, the control, while others receive varying types or amounts, the treatments. Randomization is another critical aspect of experimental design. By randomly assigning treatments to different plots or plants, you minimize bias and ensure that your results are statistically valid. Additionally, consider the replication of your experiment. Conducting multiple trials increases the reliability of your findings and allows for more robust conclusions. When designing your experiment, also take into account environmental factors such as soil type, weather conditions, and pest pressures. These variables can significantly impact your results, so it's crucial to either control for them or document them thoroughly throughout the experiment. By carefully planning your design, you set the stage for meaningful data collection and analysis. Data collection and analysis. Once your experiment is underway, diligent data collection becomes paramount. Establish a systematic approach to recording observations, measurements, and any other relevant information. Depending on your research question, this could involve tracking plant growth rates, yield quantities, soil nutrient levels, or pest populations. Consistency in data collection methods is vital for ensuring that your results are reliable and can be compared effectively. After collecting data, the next step is analysis. Statistical tools can help you interpret your findings and determine whether the results support or refute your hypothesis. Common statistical methods used in agricultural research include ANOVA, analysis of variance, and regression analysis. These techniques allow you to assess the significance of your results and draw meaningful conclusions. It's also important to visualize your data effectively. Graphs and charts can help convey complex information in a digestible format, making it easier for others to understand your findings. Remember that clear communication of results is essential for influencing agricultural practices and policies. Drawing conclusions and sharing results. The final step in conducting an agricultural experiment is drawing conclusions based on your analysis and sharing your findings with the broader community. Reflect on whether your results answered your initial research question and consider any unexpected outcomes. It's essential to acknowledge limitations in your study as well. No experiment is perfect, and recognizing these limitations can provide valuable context for future research. Sharing your results can take many forms. Consider publishing your findings in agricultural journals, presenting at conferences, or even engaging with local farming communities through workshops or seminars. The goal is to disseminate knowledge that can lead to improved practices and innovations in agriculture. Moreover, encourage feedback from peers and stakeholders. Engaging in discussions about your findings can lead to new ideas and collaborations that further advance agricultural research. Remember that the ultimate aim of conducting an agricultural experiment is not just to satisfy curiosity, but to contribute positively to the field of agriculture. In conclusion, conducting an agricultural experiment is a structured yet dynamic process that requires careful planning, execution, and communication. By defining a clear research question, designing a robust experiment, diligently collecting and analyzing data, and sharing your findings with others, you can make significant contributions to agricultural science and practice. Embrace this opportunity not only as a means of personal growth, but as a way to foster innovation that can benefit farmers and consumers alike. The future of agriculture depends on our ability to ask questions, seek answers, and share knowledge. So let's get started.